Hello geometry students, this is Mr. Fugay, and in our video today we are going to talk about a special case in finding trig ratios, and that is coterminal angles. So a quick overview to remind you what a coterminal angle is. This is an angle that is coterminal angles are angles who have the same terminal side but different rotation. So a classic example that's easy to know here is that 0 degrees and 360 degrees are the exact same. And just to show you this on our interactive unit circle, there it is. Okay, here's 0 degrees right there. If I now rotate it 360 degrees, you'll see, well, I end up with the same thing. And so this is ultimately a strategy we want to use. If we look at a problem like here, 510 degrees, and we're being asked to do something with it, it is much easier for us to ensure to find its coterminal angle that is between 0 and 360. That means it's inside of our unit circle. It's also, our trig toolbox makes more sense to use in those situations. In radian world, of course, this is going to be 0 to 2 pi. And so essentially the shortcut of this lesson, or the summary, is that anytime you have a trig ratio that is bigger than 362 pi or negative, is that you will find its coterminal parent angle that's between that 0 to 362 pi range. So for example, when I'm looking at a 510 degree angle, the first thing I'm going to do is I'm going to subtract 360 from it. And the reason I'm going to do that is because, let's subtract that 360 from that, and that gives me 150 degrees. That means, guys, that 510 and 150 will act the same way. The sine of 510 is the same as sine of 150, and here's a quick reason why. So let's look at 150 degrees on our unit circle, and there it is, okay? And you will actually see that it's one of our special one of our special angles here, 5 pi over 6, or cosine is negative root 3 over 2, sine is 1/2. Well, if I saw 150, I would probably have recognized that number, especially as you do more practice with this. I wouldn't have seen that with a 510. Even though 510, here it is, ready? I'm going to go 360, and then I'm going to go an additional 150, which brings me, well, to the same exact place I was anyways. So that's the reason why we want to use this. Now, in the case of radians, the easiest way to do this is, since we're dealing with 11 pi over 4, is that 2 pi in the world of fourths is actually 8 pi over 4. So that's going to give me 3 pi over 4, which means I'm going to treat the 11 pi over 4 as if it is a 3 pi over 4. So let's look at a couple examples of how this can be done. It's really only adding one extra step to the process that we've already learned. Here is that trig toolbox and unit circle that we need to use as we're doing these. But right away, the first thing I'm going to see is that I have a big number here, 585. And so if I subtract 360 from that, it's going to actually give me 225, which means that this question really is nothing more than just asking what is sine of 225. And so if I'm using my trig toolbox in this example, I know that 225 is going to put me into quadrant 3. Quadrant 3 tells me that the answer will be negative. 225 has a reference angle of 45, and the sine of 45 is 1 over root 2. We can confirm this answer on the unit circle if you look right over here. Sine is, of course, the y value. There is 225, so we can confirm that the answer is on the unit circle as well. Much easier to deal with than dealing with a 585. Now, if we look at something that's negative, we can still do the exact same thing. So for negative 240, I'm going to add 360 to it and recognize that this is the same thing as if I was asking for tangent of 120 degrees. Just like the last problem, we'll look and see that that's in quadrant 2, which is a negative answer. 120 has a reference angle of 60, and so the tangent of 60 degrees is root 3 over 1. There is my final answer of negative root 3. Now, this doesn't change when we're dealing with radians and reciprocals. So if we look here at the next one, cosecant of 7 pi over 3, I'm going to immediately subtract 6 pi over 3 and recognize that this is the same thing as if I was asking for cosecant of pi over 3. Cosecant, remember, is the reciprocal of sine. Pi over 3 is in quadrant 1, which is a positive answer. And pi over 3 is a reference angle of 60. So I'm going to find the sine of 60 and then flip it. So sine of 60 is root 3 over 2. So when I flip it, I get 2 over root 3. And one more, if we're still dealing with negatives, we can do the same idea here. So in the world of 6, now this might be a little harder to figure out, but we have negative 5 pi over 6. I would add 12 pi over 6 to it. That's the equivalent of adding 2 pi. So really you're just asking, well, what's negative 5 plus 12? And that is 7. So this is really the same question as cosine of 7 pi over 6. And just like all the others, I'm using the toolbox here, this is going to be in quadrant 3. Cosine is negative in quadrant 3. And then 7 pi over 6 has a reference angle of, what's that, 30 degrees it looks like? Because it's over 6. And so the cosine of 30 is root 3 over 2. And there we have it, negative root 3 over 2. And just in case you wanted to confirm, there's the x value right there of 7 pi over 6. So we can confirm that that's the correct answer as well. And guys, that's the lesson here. That's what we need to practice. So let's go back to our original note sheet. That's this one here that starts at the top, finding trig ratios of special angles. And we went through set 1, we went through set 2. What I would like you to do right now on this video is to press the pause button and take a moment and see if you can try these 6 questions using whatever method works for you. Grabbing that memorized unit circle or using your trig toolbox. Remember, we need to figure out what their coterminal angles are and then evaluate the answers from there. So go ahead and take a pause and then we'll talk about it here in just a moment. All right, welcome back. So the first thing I want to do here is show you what the answers are so that you can just immediately check and see how you did. So there are the answers for those 6. Now what I'm going to do in the remaining time in this video is walk through how I got those answers that I did in these 6 problems. So if you're looking at this and you got all 6 right, you can probably stop this video and move on to the practice and move on to the next stage of this. If you got some of these wrongs or you would like to have additional guidance in walking you through this problem, well, let's go ahead and go through that. So I'm going to erase everything and we're going to walk through these in as much time as I have left to record here. So let's get all of this erased first and let's begin. So I'm going to be using the trig toolbox and that's how I'm going to walk through this. Remember that if you have a memorized unit circle, this is going to work as well. So let's go ahead and grab this. And I'm really just going to focus on the toolbox. So I'm going to leave that up here and let's just clear out some of this stuff. All right, let's begin. So there's my toolbox up top and we'll go full screen. All right, so 13 pi over 6. Right away, I'm going to subtract 12 pi over 6 from it. That's my 2 pi. And recognize that this is just the same thing as sine of pi over 6. And that's nice because that's going to tell me that we're in quadrant 1, which is positive. And we have a reference angle here of 30 degrees. So we're just going to take the sine of 30, quite literally. The answer for this first one is 1/2. Moving to the next one, we are again in radians. The 2 pi in the world of fourths is 8 pi over 4. So that's what I'm going to add to this. And so what we have is cosine. So it's 8 minus 3. So 8, 7, 6. That's 5 pi over 4. We'll ask those same questions. 5 pi over 4 is in quadrant 3. That makes it negative. And then we have a reference angle of 45. So we're going to find the cosine of 45, which is 1 over root 2. Throw that negative sign. That's a 2, by the way. That's not a 3. So why don't I get that eraser here and we'll fix that just so you have it there. All right, there it is. Negative 1 over root 2. All right, continuing on, we're going to move on to a tangent problem. 11 pi over 4. So again, in the world of fourths, that is 8 pi over 4. So 11 minus 8 is going to be 3 pi over 4. So this is the same as tangent of 3 pi over 4. That's in quadrant 2. Tangent's negative in quadrant 2. And the reference angle is 45 degrees. So let's find the tangent of 45. That's 1. And then we're going to throw a negative sign in front of it. So there is how I found those first 3. Now, let's take a look at the next 3. Now, these are some other mixtures here. So we're going to take negative 300. Now, we're back to degrees. So to get its equivalent, we're going to add 360. That means we are dealing with tangent of 60 degrees. And this one's pretty nice because we know it's positive, and we're just going to go to our triangle and get tangent of 60. Opposite over adjacent, the answer for this one is just square root of 3. Back to another radian one, negative 2 over 3. Well, we're going to add 6 pi over 3 to it to get a positive value for it. So its equivalent ratio is cosine of 4 pi over 3. That is going to put me into quadrant 3. That is a negative value for cosine. and then the reference angle here is 60. So let's go find the cosine of 60. That's going to be 1/2, and we'll throw that negative sign in the front of it. And for the last one, 510, we're going to subtract 360 from that. We get 150 degrees. That is going to be in quadrant 2. Sine is positive in quadrant 2. And this has a reference angle of 30 degrees since we're 30 away from 180. Sine of 30 is going to be equal to 1/2. And since this is positive, we don't really have to put a sign in front of it. So that is how these coterminal values work. So now I want you to take some time to practice some of this on your own. Check the lesson plan page or check with your teacher, whether it's me or someone else, to see what problems you should be working on as we focus here on these coterminal values. I hope this video was helpful, and I hope also you all have a great rest of your day.